So this video is going to take a look at section 9.2. Good news for you, there's going to be a lot less vocabulary, a lot less babbling on about just random terms, and a lot more of just working through examples. So in section 9.2, we're going to look at multiplying polynomials. Remember, the last video looked at adding and subtracting them. So now we're looking at multiplying polynomials. And again, very straightforward. By the end of the lesson, hopefully you understand and can multiply polynomials. So the first deal here, part A, we're just going to look at a bunch of examples here. It says find the product, multiply and simplify. So when you multiply two terms, okay, you multiply their coefficients. So I'm going to multiply, let me get my board tool set. All right. So I'm going to go ahead and multiply the 2 and the 5. Well, 2 times 5, I think we all agree, is 10. And then I have x times x. Remember, when you're multiplying, to combine them, you add their exponents. So x times x is just x squared. Okay, so part A, the final answer would just be 10x squared. As we go through these, if you feel confident, I would just pause the video and then maybe fast forward through and double check all your answers and see what you're getting. Okay. Part B, distributive property, got to go to both guys inside. When I multiply, again, multiply your coefficients first. So when I multiply x times 3x, I have 3. X times x is going to be x squared plus 5 times the imaginary 1 out in front there is just 5, and I just have 5x. So that there would be my product of x times 3x plus 5. All right. Part C, again, just distributive property. We're just distributing to all three terms inside. So I have negative 2ab times 6a cubed. Multiply your coefficients. Negative 2 times 6, negative 12. I have a and a to the third. To combine them, I have a to the fourth. Add your exponents. B is just b. There's no other b to combine it with. Then I have negative, for the second term, I have negative 2 times negative 4. That's positive 8. A and a makes a squared. B and b makes b squared. And then finally, I have negative 2 times the coefficient there is just an imaginary 1. So I have negative 2. I don't do anything with my a because there's no a there in that last term. But then I have b and b to the fifth, which makes b to the sixth. And I can't simplify anymore because, again, my exponent or my variables are not the same in any of them. And so that would be my final answer there for that product. And again, you'll see as you get comfortable using distributive property, hopefully this all makes sense to you. That's all it is a distributive property, and then looking back at the properties of exponents from chapter 8. Okay? Again, if I'm going to multiply this and simplify, well, these first two terms multiply 10 times 3 is 30. X and x makes x squared. Minus 2 times 11 is 22. X and x makes x squared. And I can go one more step now since I have x squared and x squared. Since those are the same, I have 33x squared minus 22x squared. 33 minus 22 is just 8x squareds. Okay, again, a lot of this is probably very familiar to you. So I don't think there's any need to belabor the point. I'm just going to go through and work through these examples, talk through them, and you can go back and rewatch as often as necessary. Okay, so again, distribute that guy. So I have a squared and a makes a to the third plus 2a squared minus, now this minus gets distributed with the a squared. So negative a squared times that is negative 3a to the third. Negative a squared times negative 4 is actually going to be a positive 4a squared. And now I identify any common terms. Okay, or any common terms. So I have a cubed minus 3a cubed. A cubed minus 3a cubed is negative 2a cubed. Then I have positive 2a squared, positive 4a squared. Positive 2a squared and positive 4a squared make a positive 6a squared, and that's as far down as I can go because I can't combine them any further. My exponents are different. Again, I think this is stuff that you're already familiar with. If you're not good with those properties of exponents from last chapter, obviously you need to go back and rewatch some of those videos and get yourself comfortable with those properties. Otherwise, you're going to be in a world of hurt here. Okay. The second type of examples here are extended distributive property type problems. So in other words, I'm going to take this x to every single guy inside first. Okay. So I take that x to everything inside. X and 5x squared makes 5x cubed. X and 4x makes 4x squared. X and 3 makes positive 3x. And then I have to take the 7 to every single guy inside. So 7 and 5x squared makes 35x squareds. Okay? 7 and 4x makes positive 28x. 7 and 3, positive 21. And then again from here, identify your common terms. Okay? I don't see any other x cubed. So I'm pretty sure 5x cubed is going to stay out in front. All right, so then I got to identify my x squared. So I have positive 4x squared, positive 35. 4 and 35, pretty sure it makes 39x squared. Then I see positive 3x, positive 28x. 3 and 28, 31x's. And lastly, the 21 is left all by itself. And so that would be my product here. Multiply and then simplify. Again, my encouragement to you is very simply pause the video, work through these, see if you get the right answer. Okay? Distribute the 3x to everything. I'm going to go quickly. So 3x and 2x squared, that's 6x to the third. Add your exponents. 3x and x makes 3x squared. And negative 5 and positive 3x makes negative 15x. Okay? Again, this is where you have to be careful. This negative 1 gets distributed to every single term inside. So negative 1 times 2x squared minus 2x squared. Negative 1 times positive x, negative x. Negative 1 times negative 5, positive 5. Again, identify your common terms and just combine them. Okay, I only see one term with x cubed, so 6x cubed stays out in front. Positive 3x squared, negative 2x squared. 3 minus 2 is positive 1, x squared. Then I have negative 15x minus x. Negative 15 minus 1 is negative 16x's. And the positive 5 is going to hang out on the end there, and nothing's going to change there. All right, so again, just distributive property 2 times over, and then you have to simplify everything down by adding. All right, so again, just some more examples for you to look at. I'm not going to go through and do all of these. This second example down here is a little bit more extensive. It's just a lot more work, okay? And I'm just going to explain what you're going to do, and I'm going to let you guys do it. So you're going to take the x squared to all 3 guys over here, and then you have to take your negative 2x to all 3 terms, and then you're going to take your positive 2 to all 3 terms, and then you'll simplify all of that. Okay, I'll go ahead and do this really quick just so you guys have a way of checking your answer. So I'm going to end up with x to the 4th plus 2x to the 3rd plus 2x squared minus 2x to the 3rd minus 4x squared minus 4x. And then finally I have plus 2x squared. I'm going to run out of room here. Plus 4x plus 4. Okay, and then I combine like terms, and I only have one term with x to the 4th. So I have x to the 4th. I have positive 2 minus 2. That's all I have. So those are going to cancel. So I don't have any x cubes. So then I look at my x squared. 2x squared minus 4x squared. That's negative 2x squared plus 2x squared. Well, negative 2x squared plus 2x squared. Those are all going to cancel as well. So then I look at my x's. I have negative 4x. I have positive 4x. Oh, those cancel as well, and the only thing left is down there is positive 4. So that worked out pretty well where everything kind of canceled and made our lives a lot simpler, a lot quicker, a lot smoother. Okay, and again, you'll notice on your paper you obviously have a ton of different examples to look at to make sure you understand how to use that distributive property. The one term that we're going to use when multiplying binomials, remember a binomial is a polynomial with 2 terms. So these would both represent 2 different binomials. When we're multiplying binomials, we're going to use the FOIL method. It's an acronym. F stands for first, O stands for outside, I stands for inside, and L stands for last. Okay, and so essentially what it means is if you're going to use the FOIL method, you identify the first terms in both polynomials. Okay, in other words, you would take A and C since they are first, and you would multiply them together, and you'd end up with AC. And then the O stands for outside. A is all the way to the left, D is all the way to the right, so I would multiply those 2 things together and get AD. And then you take your inside terms. The two terms that are inside and closest to each other are b and c. So I multiply those two. And then finally, I got to take the last term. So I have b as the second term, d is the second term. And so I end up with bd. It's harder to see with variables. Hopefully it makes more sense here as we look at a few examples using the FOIL method. Okay, so using the FOIL method here, I have to take my first terms, m and m. Well, m and m makes m squared. And then I have my outside, outside m and 2 makes 2m. Then I take my inside terms, 5 and m makes positive 5m. And I take my last terms, positive 5 and positive 2 makes positive 10. I go one more step here and simplify, so m squared plus 2m and 5m is 7m plus 10. All right, so that's how I'd utilize the FOIL method there. Again, FOIL method, okay? First terms, x and x squared. Outside, x and negative 7, that's negative 7x. Negative 3 and x, those are inside terms, so negative 3x. Negative 3 times negative 7 is positive 21. Combined like terms, negative 7 and negative 3x make negative 10x. So I have x squared minus 10x plus 21, and that would be my resulting trinomial. Okay, again, FOIL method, I'm not sure if you've seen it in previous courses. If not, that's something that we're going to go back to quite a bit, so make sure that you're comfortable with it as we move forward here. Okay, and again, just plenty of more examples of you working with the FOIL method. You'll notice I'll do part D here because it does have two different variables in it. It has x and y. Really no different here, same process. So when I go through and I do this, 7x and x, first terms, 7x squared. Outside, 7x and negative 4y, that's negative 28xy. Inside terms, positive 5y, positive x, that's just positive 5xy. And I have positive 5y, negative 4y, that's a negative 20y squared. Combine any common terms, I see xy and xy, and so I have 7x squared. I have negative 28xy plus 5xy. Negative 28 plus 5 is negative 23xy's minus 20y squared. Okay, and so that's all we'll do there when we have more than one variable. You'll still identify they have to have the same exact variables, same powers and everything. Okay, and obviously that concludes section 9.2 on multiplying polynomials. Any questions? Have them ready.